Okay, this is part 4 of our 8.8 AP Calculus volumes, cross sections, semicircles, and triangles. Here I'm going to show you how to do an example with a triangular cross section with a pretty simple function. So here is our process again that we always do when we're doing these cross sections. We need to, this time though, when we're doing triangles, we have to have a description in the problem of the relationship between the height and the base of the triangle. So here I'm going to let f of x equal ln x. My triangular cross sections are perpendicular to the x-axis where the height is 2 units longer than the base. The height of the triangle. Triangular cross section, yes, 2 units longer than the base. The base defined by the region bound by f of x, the line x equals 10, and the x-axis. So we're going to start like we always do by sketching the graph of the region. There's y equals ln x. Here's x equals 10. We're going to sketch one rectangle inside the region, the width of which is dx. This is 1, goes to 10. Okay, I'm going to pull that one rectangle out. I'm looking at this as a cross section. The width is dx. The length of that rectangle is ln x. Recall, well, let's go ahead and draw the triangular cross section. This is what a triangular cross section would be. Okay, recall that it also tells us that the height of the triangle is 2 units longer than the base. This is going to be 2 plus ln x. That's the height. Recall that the area of a triangle is equal to 1/2 base times height. And so if we're going to get the volume of this one cross section, we are going to do the area of the triangular face, which is going to be 1/2. The base is ln x. The height is 2 plus ln x. And then times the width of the cross section, dx. That's the volume of one of these triangular cross sections. If we're going to do all of them to get the entire volume of the entire solid, we're going to integrate from the lower limit to the upper limit of integration. And we'll do all of these cross sections. So that means we're going to have, we'll pull the 1/2 out, ln x times 2 plus ln x times dx. And if we have to just set up the integral, we're done there. If we have to evaluate that on a calculator portion, recall that we wanted to put all of that inside parentheses. And so I'm going to type that in my calculator, see what it gives us. I'm going to do 0.5, math 9 gives me the integral. Limits of integration are 1 and 10. Then I'm going to type in, again, this is all inside the parentheses, so we can just type that in like we need to, like it is. ln x. I'll do it to close parentheses on the ln x. And then times, open a new set of parentheses, 2 plus ln x. We're going to have to close parentheses on that ln x also. Then I close parentheses again. And so what that looks like in my calculator, when I've typed everything in, is 1/2 times the integral from 1 to 10. It opens automatic set of parentheses. It's ln x. And then I open a set of parentheses, 2 plus ln x. Sorry, it's got parentheses around the x there, around the x here. I have to close these two parentheses. And then it's automatically got everything contained in there times dx. And when I tell it to calculate that, it gives me 26.509, and that would be units cubed. And that's how we do a triangular cross section.